Sunlight travels 150 million kilometers to paint your sky blue. Welcome to today's video. This video is about why is the sky blue? Thousands ask this every day, yet fewer than 1 in 10 know the answer. It's one of the oldest and most universal why questions of all time, asked by kids, adults, and curious thinkers everywhere. Even though we see the sky every single day, very few people truly understand why it glows with such a soft blue color. Before we dive into the science, here's a quick curiosity hook. Take 10 seconds and think. If sunlight is actually white, what would be your best guess for why the sky doesn't look white? And why does the sky turn orange and red during a sunset, but deep blue in the middle of the day? The answer involves invisible molecules, bouncing colors, and a surprising trick of light that's happening above your head every single second. Let's break it down into simple, everyday science. When sunlight reaches Earth, it doesn't just pass straight through the atmosphere. Instead, it hits tiny particles, air molecules, gases, and dust floating high above us. Sunlight might look white to our eyes, but it's actually made of a rainbow of colors, each with its own wavelength. Some colors have longer wavelengths like red, and some have shorter wavelengths like blue and violet. Here's where the magic happens. When sunlight interacts with air molecules, the shorter wavelengths, especially blue, scatter in every direction. Imagine a cascade of blue light bouncing off minuscule particles suspended in the air, creating an expansive hue that envelops the sky. This vivid display of dazzling blue is due to what is scientifically known as Rayleigh scattering. It's the key to why the sky is blue. Think of it like throwing a handful of tiny bouncy balls inside a room. The more petite, lighter balls bounce around wildly, hitting everything. The larger ones barely move. In the atmosphere, blue light acts like the tiny balls that scatter the most, so your eyes see blue coming from all directions in the sky. To put it simply, small balls equals short waves equals blue light. This helps close the loop and reinforces the analogy. But wait, if violet has an even shorter wavelength than blue, why isn't the sky violet? Here's an interesting thought. Why aren't we bathing in purple light? Take a second to ponder this puzzling question. Ready for the answer? The answer lies in 2 factors. First, our eyes are less sensitive to violet light than to blue light, meaning we perceive less violet overall. Secondly, much of the violet light is absorbed higher up in the atmosphere due to processes such as ozone absorption. As a result, the scattered light that reaches our eyes is primarily blue, which is why the sky appears blue instead of violet. During sunrise and sunset, the story undergoes a dramatic change. As the sun dips closer to the horizon, its light dances through a thicker layer of atmosphere. The scene unfolds with the gentle hum of evening crickets, the earthy scent of cooling ground, and the first stars peeking through the dimming light. By the time it reaches your eyes, most of the blue light has already scattered away. What's left? The longer wavelengths red, orange, and warm gold. That's why sunsets look like paintings, with swirls of color stretching across the sky like brushstrokes on a vast canvas. This everyday science concept also explains why astronauts see a pitch-black sky in space. With no atmosphere to scatter sunlight, nothing spreads the colors around. The sky remains dark, even when the sun is shining directly on it. Nothing. But the blue sky you see isn't always the same shade. On hazy or polluted days, particles scatter light differently, causing the sky to appear pale or washed out. For example, during a city smog event or when wildfire smoke fills the air, the sky may take on a muted, grayish hue. After a storm, when the air is clean, the sky looks deeper and more vibrant because fewer particles are blocking or diffusing the scattered blue light. So when you step outside and look up at the sky, you're witnessing billions of tiny interactions between light and air happening at incredible speed. The sky is blue simply because Earth has an atmosphere, a thin, delicate blanket of air that transforms plain sunlight into color. To deepen your understanding, try this sky watching challenge tomorrow. Observe the sky at different times of the day and take note of any changes in the shade of blue you see. This simple activity will help you experience firsthand how the science you've discussed comes to life in the world around you. Let's bring this into a relatable example. Imagine shining a flashlight through fog. The light appears diffused and glows outward because the tiny water droplets scatter it. Now imagine that happening on a planet-wide scale. The sunlight scatters through the fog of tiny air molecules in our atmosphere, giving the sky its iconic color. To see a similar effect at home, try this experiment. Mix a small amount of milk in a glass of water and shine a flashlight through the mixture. You'll notice the beam of light scatters and creates a bluish hue, mimicking Rayleigh scattering. It's a fun and easy way to see how light and particles interact. Understanding why the sky is blue isn't just trivia, it reveals the beauty of physics all around us. It's a reminder that even simple moments, like looking up on a clear day, are filled with hidden scientific wonders. And here's a fun extension. If you traveled to another planet, the sky might be a completely different color depending on the atmosphere. On Mars, the sky looks reddish and sometimes even brownish because dust particles scatter light differently. Similarly, on Titan, one of Saturn's moons, the thick hazy atmosphere gives the sky a soft orange hue. Venus, with its dense cloud cover of sulfuric acid, creates a yellowish sky, adding to its mysterious allure. On a planet with a thicker or differently composed atmosphere, the sky might be green, purple, or even yellow. The next time someone asks, "Why is the sky blue?" you'll know the honest answer: the beautiful interplay of sunlight, wavelengths, and scattering that fills our world with color. If you enjoyed this video and want to learn more fascinating science facts, hit like and subscribe. For the full playlist, the link is provided in the description. Thanks for being curious with me today. I truly appreciate your time and interest. Stay tuned for more exciting content.